Right. Example 9, second last example. So there's two titanium spheres approaching each other head on with the same speed of 3 meters per second, and then it collides elastically. After the collision, one of the spheres whose mass is 500 gram remains at rest. Okay, calculate the mass of the other sphere. Okay, so let's try and draw a sphere. This is A. So this one I would say this one is 0.5 kilogram, and then this one also starts with 3 meter per second, and then the final velocity remains at rest, so this is 0 lah. Okay, and then we have the second ball B. This one is unknown, and then the initial we know, which is 3 meter per second, and then the final velocity for the second sphere, which is B, is unknown as well. Okay, so how do we do this is we have to use two equations because we have two unknowns, so we can't solve this with one equation only. Okay, so what are the equations we are using? First, we have to use the conservation of momentum. Okay, so can you guess the second one? Well, we are using the second equation to be the kinetic energy. Okay, so this is an elastic collision. So dimensions ini collide elastically means this is an elastic collision. So we know that for elastic collision, both the total momentum and the kinetic energy is conserved. Okay, so since there's two unknowns, we are gonna be using both. Okay, so let's start. So initial MAUA plus MBUB equal to MAVA plus MASA plus VB. Okay, so substitute 0.53 plus unknown, this one is 3, MAVA is 0, so directly 0, this one is unknown as well. Okay, so we then have UA let me read again. This one remains at rest. Okay, so before we have to consider the direction, right? I forgot, I'm sorry. Okay, so UA is going to the right, this one is going to the left, means one of this should be negative, so this one should be negative 3. Okay, why negative 3? Sebab sekarang they are doing a head-on collision, so one should be going to the right, one should be going to the left lah. Okay, so let's continue. So we have MBVB equal to 1.5 minus 3 MB over belum lagi over, after this baru saya akan turun. So we can then let the final velocity of B to be this equation. Okay, so this is equation 1. Okay, so we have used this, now we have to use this equation. Okay, so total kinetic energy is equal to total final kinetic energy. So we know that kinetic energy punya formula is half mv square. Okay, remember the square di belakang tu. So half MAUA square plus half MVBVB square V pula UB square equal to half MAVA square plus half MBVB square. Okay, banyakan square dia. Confusing ni, banyak square ni. Okay, so substitute half MA is still 0.5. UA is 3 square plus half MB is unknown. And then UB is negative 3 square. And then VA is 0 plus half MB VB square. Okay, and then simplify this everything. You'll then get MBVB square minus 9MB equal to 4.5. Okay, so this is your second equation. Okay, this part is very tricky. Make sure tidak salah langsung. Kalau salah satu je, your equation would be automatically wrong lah. Okay, now we can subs 1 into equation 2. So, MB VB is 1.5 minus 3 MB over MB lagi. This is square. And then minus 9 MB equal to 4.5. Rearrange and calculate. You'll then get the mass of the second sphere to be 0.167 kilogram. Okay? Boleh? So that is your example 9. So this type of questions, remember if there's two unknowns, you have to use two equations. Okay? But if there's only one unknown, you can just use one equation lah. Okay? Right, so that is example 9.